Gonna stop. Every so often I start recording and then the camera just says, screw it. And then it like stopped and QuickTime says, I'm sorry, I'm telling you what it's like to make these videos. Sometimes there's technical difficulties. So we're talking about linked lists, and we're gonna start talking about what is a linked list and how do we talk about where the linked list begins and where the linked list ends. Okay, so a linked list consists of nodes. Okay, the node, as we now know, is data. Okay, and a link, or sometimes called next, or what other things? A link, a next to the next node, etc. Okay, and so a linked list consists of nodes, and since a node is used in a linked list, when we create our linked list class, if we will, and actually it won't be called a linked list class, it'll just be called a list class. Okay, and we'll talk a little more about that later on. But we'll create our list class, and it'll be based on a linked list. So when we create linked lists, okay, what we're going to be doing is we're going to have, so like we're going to have something like this. We're going to have public, let's just call it linked list, and don't make it public, I'm sorry. We're going to have class linked list. Okay. That looks pretty normal, right? And inside here, we're going to have something called a private inner class node. Okay, you might have not seen this before, but all that means is that the inner class can only be used by the outer class. Okay, so people can't make nodes, but only linked lists can make nodes. There's not like a notion of a node being used outside of the linked list class. And this is a common pattern in Java where you're like, okay, this class is going to depend on this class, so I'm going to just stick this other class inside of this class because there's no real reason I'd want to use it outside of it. Okay, and that's really cool because it connects these two things together. You don't have two files running around because you can't really do a linked list without a node class, right? And there's no other kind of reason for this node class unless there's no other really use for it other than in a linked list, for example. And so you might make it a private inner class. You don't have to. You can make two classes. You can make a node class and a linked list class and do it that way too. Doesn't matter. Okay. So now, how does a linked list class work? So let's say we had a node class. Okay, and it could be a private inner class of the linked list. Okay, it has data and let's call it link. I like link. Okay, little Zelda-y, right? And then we have a linked list class. Okay, and what are we gonna have? Well, we're gonna have one private variable, and it's going to be node head. Okay, and what does head mean? Well, we call the head of a linked list where the linked reference to the first node of the linked list is a reference to the first node of a linked list. Okay, so we have head up here, and it references the magic place in memory that's the first trained car of a linked list. So sometimes what I'll do is I'll say, like, let's say we had the list 492. Okay, I would have the head points to the first node of the linked list, which is 4, and and then 4 points to 9, and 9 references 2. Remember, point and references, I'm going to use them interchangeably. So, and 9 references 2. So 4 has a reference to 9, 9 has a reference to 2, head is a reference to the first value. Okay? So hopefully that makes sense. All right, and so, good. So head is a reference to the first node of a linked list. Okay? And what else? Head is a reference to the first node of a linked list. Oh, yeah. And then the last node of a linked list points to null. Okay? So the last node of a linked list and the last node, the link of the last node of a linked list is null. Okay? Okay, and object types, our reference types always actually default to null until we give them values. Okay, so like if I have ball, my ball, and I haven't invoked a constructor on it yet, my ball is null. Okay, and before I can actually say my ball dot, I have to run the constructor on it with new so that my ball references data on the heap, and then I can say my ball dot and be able to get, I have to use the constructor to give it a velocity and an initial position and an initial width and height or whatever, right? And once I do that, then it's referencing it on the heap, okay, and so then I'll have these values. I'll be able to get the position, right? Because I've given the private variables, initialize the private variables, right? Which is the point of a constructor. Okay, you know that already. Just reiterating. So, 2, its length will reference null, okay? And that's a Java thing, having these object types initially reference null, all right, until you get them to explicitly reference something. That does not happen necessarily in other languages, which leads to, like in C++, for example, early C++ leads to a crazy behavior if there's some junk value in here that then takes you to a place in memory that you're not supposed to be. Okay, and that's called a segmentation fault. So that just means you're trying to read or write outside of the segment that your program's given, right? So if I'm in the Java program and I try to read Safari data by just putting in like a random reference there and grabbing that data, it'll be like, you can't do that. Your operating system will say, this program can't just start reading the memory of the whole computer. It's a security flaw, right? If I create a program that did that, and then I could read the memory of your computer and like send it back over the internet to me. So they don't let you do that, and the Java way of doing that is much more cleaner than the C++ way of doing that. Because everything starts at null, and then you can make it reference anything in the program. Okay, so the head of a linked list is a reference to the first node in the linked list, okay? And the last node of a linked list references null, okay? So that's how you know where the linked list starts and where the linked list ends, okay? And the linked list, well, it has one private variable, and that is head, okay? And so it's at one private variable, and that is node head, okay? And the node has 2 private variables, so 2 privates, right? 2 privates, 1 private variable, 2 private variables. Okay. The node has two private variables, data and link. Okay. And data is data, right? It could be a primitive or object or whatever, right? You don't know what it is. We're doing data of integers right now. Okay. So primitive integers. And link is the next node. Okay. And so you can imagine head is pointing to a node, and that node is referencing another node, and that node is referencing another node. So it's like head is a reference, just like link is a reference, okay? And so head references a node, and then link references another node, et cetera, et cetera. Okay, so both link and head are node references. Data is the actual numbers, okay? So notice head doesn't have any data to it, but it references a node that clearly has data, right? So I'm sorry, that's going to be confusing. Head is referencing a node object in memory, and that node object has data. Okay. The final thing here is how do you know? So a linked list is empty. Well, when head is referencing null. Okay. So when head points to null, linked list is empty. And null is a keyword in Java, okay? And null, you can set any object type equal to null. And what that'll do, if you explicitly set, so if I had ball, my ball, for example, my ball equals new ball, whatever. So I invoke the constructor and give it a bunch of private variables, or give it values for all its private variables. And then later on I say my ball equals null. What'll happen is now my ball references null, nothing references that new memory that I put on the heap, and so that memory will eventually be garbage collected, a term we learned earlier in these videos, which means that memory will be released and be able to be used by other programs because nothing's referencing it. Unless some other thing is referencing it. If nothing is referencing it in the program, then Java says, okay, let's collect it. If something else is referencing it, then it doesn't get garbage collected because it's still useful to the user or whoever happens to be programming. Neither here nor there. Okay, so head equaling null means that we have an empty list, and head equaling these things of a list means that we have if head points to a node, that means we have stuff in our list, okay? All right, so now a few questions, and then we'll keep on going on linked lists. Our interesting non-contiguous list data structure.